Welcome to QBD Works, DOE Deep Dive. First, the basics. Today's key concepts are the scientific method model for experimentation. Secondly, experimental approaches, one factor at a time, factorials, etc. And finally, when to use factorials most importantly. Before we talk about design experiments specifically, let's talk about experiments in general. First, you want to ask, why do I want to experiment as a scientist in the industry or in academia? And then take a few seconds to answer to yourself, how can you define an experiment in your own language? Let's first talk about why. Why? So why experiment? As a scientist, I like to predict my process. So I like to foresee what the outcome of my process is after tweaking a few knobs here and there, process parameters and so forth. The experimentation is a manipulation of controllable factors at different levels to see their effect on responses in the face of noise. So basically, if you have a process, and we call this a black box or biologics, you control, these are controllable factors, basically knobs that you can turn or buttons you can push, and you can change the levels of these parameters. For example, centrifugation time, nutrient time, temperature, inoculum concentration. And then we'll see a response which in different measures that we will take. In this case, protein recovery, protein quality, and these are called outputs and responses. In the face of noise, of course, there are many other things that you cannot control on a regular basis. For example, the type of operators, the number of operators that will be producing these outputs, as well as the vendors. They will change over time, and you cannot always see how the vendor is producing the raw materials and so forth. In QBD terminologies, these are called the process parameters, PP, sometimes critical based on how you define critical, so CPP. Outputs basically will be the Y's, and the QA's, quality attributes. It sometimes depends on how you define criticality, but it would be critical quality attributes. In Lean Six Sigma world, I call Y or CTQs, and as well as these are X's. And the noise, and you'll have some, this will depend, material attributes is also another terminology used in QBD, will be either included in the control factors or in the noise factors. But there is always noise, as we've seen in the previous case. So when you change the levels of these input factors, make sure makes a bigger response on the Y's or the quality attributes than, so that it can overcome the level of noise. So you want the signal to be this. So the only signal you'll be seeing is this probably, and the other is the noise and so forth. So there's a very important concept here.